2014 Senior External Physics Exam, Paper 2, Question 1. Read. A mass of 10 kilograms is placed on an inclined plane as shown in the diagram below. Given a frictional force of 20 newtons is directed against the motion of the mass, how long will it take to reach the bottom of the plane? First thing we need to do is we need to draw the forces that are acting on our mass. So coming here perpendicular to the plane, we have the reaction force. Vertically downwards, we have the weight force, W, which is equal to mass times G. And we have a frictional force opposing the motion. It's going to slide down the plane, and therefore up the plane we have a force of 20 Newton. Okay, in this particular case here, we therefore now need to sum the forces that are acting on our block. And I'm going to sum the forces for the moment that are parallel to my plane. And Newton's second law says when you sum the forces, it's going to equal the mass times the acceleration. So therefore, in the direction that it's moving, if we divide up the weight force into two components, there's a component perpendicular to the plane, and there's a component here parallel to the plane. It is the weight force parallel to the plane acting down the plane here, and because the angle of the plane is 30 degrees, the weight force here will make an angle of 30 degrees with perpendicular to the plane. So therefore, down the plane, we have a force of W sine 30, and up the plane we have a force of 20, and that's equal to the mass times the acceleration. So therefore, going through and solving this, weight is m times g, which is a 10 kilogram mass with g being 9.8, multiplied by sine of 30, which is a half, minus 20 equals our mass, which is 10 kilograms, multiplied by its acceleration down the plane. So therefore, going through this particular circumstance here, 10 times 98 is, 10 times 9.8 is 98, divided by 2 is 49, minus 20 equals 10a. So therefore 49 minus 20 is 29 equals 10a. So therefore a equals 29 divided by 10, which is 2.9. So the acceleration down the plane is going to be 2.9 meters per second squared. That's the first part of the problem. The next part of the problem now is we need to actually calculate the distance. And so the distance that it's going to take to travel. Now this is the hypotenuse. We've got 30 degrees here and we've got 2 meters per second. So therefore, in this particular case, we know that sine 30, sine of any angle equals opposite over hypotenuse. In this particular case, we're after this distance here, which is the hypotenuse, which is the distance it's going to slide. So therefore, the hypotenuse is the opposite side divided by sine 30. Now the opposite side is 2, and sine 30 is a half. 2 over half is 4. So therefore, this particular distance down our plane is 4. So now we need to use our constant acceleration formula. And with our constant acceleration formula, we need to put in our values. Now it starts with an initial velocity of 0. We know it's got an acceleration down the plane of 2.9 meters per second squared. And we know that it's got to cover a distance of 4 meters. So therefore we need to look at our formulas, which are x equals ut plus a half at squared. And we need to plug our values in and work out our answer. Our u is 0, so therefore we can get rid of that. So the distance down the plane is 4 meters. Is equal to half multiplied by its acceleration down the plane we calculated to be 2.9. A half times 2.9 times t squared is equal to 4. So therefore we solve this, t squared is equal to 4 times 2 divided by 2.9, which is 1.66. And so therefore the square root of 1.6, we get that t equals 1.7 seconds. That's how long it's going to take it to travel the 4 meters down the plane.